All right, this is a video for the first project parts, and we have these two parts, the lock and the spring. So in this video, I'm gonna show you how to make these two parts step by step. And before we start, okay, the project we do not need, we do not require strictly on the dimensions, and also you can model any way you think that's best. Okay. Also, you want to take pictures as you go because they're going to be in your report. Then, pretty much the major steps are in the slides, and the slides is on web course. See, and also we provided a model that only has solid, so you can open the model and take a look at the model. The only difference is you will not be able to see the modeling step here. Okay, you would only have a solid body, so you can't really see how I made this. And so that one is just for you to get a feeling of the solid, how the thing looks like. All right, so let's start with the this piece first. Okay, let me turn off everything. So to start, you want to build a new file, and that should be a model file in inch, and you want to find some place to save, right? Then what else? Change the name. Okay. Then basically this is two extrude, one from XY plane, the other one is from I think YZ plane. Then unite these two pieces, and the only difficulty is the sketch. So we'll start a sketch on XY plane. Then first look, it's symmetric, sort of symmetric on both sides, and a couple circles. So we'll start with the little circle here, which is 0.24 in diameter. And once you have the first one, you know this is a way out of ratio. So we'll move this to a better place. Okay. Then the second, the bigger one's 0.49. That'll be concentric. 0.49. So we'll move this a little bit over here. Then we'll keep doing circles. And you can dimension all of them, or you can use constraints. Say these two should have the same radius, these two as well. Okay. Sometimes when you pick the arc, if you move your cursor just a bit inside of the circle, you'll pick this point. And you can see the symbol here. If you move cursor here, that'll be the center point. If you move your cursor just a little bit outside of the circle, that'll be the arc. Okay, so that's because sometimes people have a hard time picking up the arcs. Now the top and the bottom are two arcs, so we'll use this arc tool, default 3-point arc. Now we'll start from here, and you just want to make sure there's one side that's tangent. Okay, then do the same for the bottom. Now on this side it's not tangent yet, so we'll select both and make them tangent. The same goes for the bottom. Then the top and the bottom, they should be equal. Right, so we'll make them equal. Then lastly, these two circles should stay on x-axis. So that is a constraint which is hard to apply by just clicking them. So we have to open this command to centers, constraint to the x-axis. Okay, so now they look better than we can add the distance between those two circles. So we'll use infer dimension from this to that, 0.265. Okay, you notice this is not in the middle. So actually, you might be able to tell there's a little reference line there. So we'll build a straight line first. Right click, and because we have the point on curve constraint on top of the line, it's hard to pick the line. So two ways: you can just wait for the three dots around your cursor, then click. You can pick everything on that spot, or you can right click and select from list. So you will be able to pick the object underneath the constraint and turn that to reference. Then we want this reference line to stay on the middle of your, the middle should be the sketch origin. That'll be the geometric constraint, midterm or midpoint constraint. So select the line constraint to sketch origin. Right? And as you can see, the four circles are constrained. Top and bottom are not. That's the distance from top to bottom. So infer dimension, we'll select the top. Be careful not to select the center of the circle. That'll be this one. So you want to move a little bit outside of the circle. Pick the arc, click, and this will be 0.55. Okay, everything's constrained, fully constrained. Oh, by the way, you don't have to fully constrain your sketch. Okay, that's just a good habit. Okay, so this curve here, from top to the middle, that is a 3-point arc, and it'll be tangent on both sides. You can tell from the constraints. So 3-point arc starts from the same point and end on the circle. You can move this point in the middle to make sure one side is constrained. So it looks like this is a little bit better. Then we'll make this tangent. So select both and make them tangent, right? Then the next is this arc. In the slides, I didn't specifically say this is actually the center is actually concentric with these two circles. And when you think about it, it's a sort of like a hook. So when you unlock the pliers, it rotates on this center. So you want this kind of like a bigger circle. So we'll use the second method for the arc, that is center. So first you want to select a center point. It will be this, and it'll start from this point on curve. So we'll try to select that point on curve. Or maybe here. And go up, overshoot outside. Okay. And we want to make sure this circle is, this arc is tangent to this circle. That'll make this back to x-axis because the center is here. Okay, then this little guy here is actually a fillet. So a fillet between these two, and radius 0.03. Okay, so sketch is fully constrained, pretty happy. And you can turn them to reference, or you can trim them off if you want to. But in this case, we can just go straight to extrude and change this curve rule, or this filter, how you select the curves. So we'll use this region boundary curve. Okay, that is basically area. You can see here, right? We want to extrude this, and this portion. So that's why we don't have to trim your sketch. But if you want to have a nice looking sketch, you can. Okay. And the thickness in the slides is 0.057. So 0.057. Okay. And if I hit enter, it'll give you a preview. So I say okay. And that is for the bottom piece. And Next is this little guy. It's banded side here. It's a bit easier for you to grab the lock. So it's another sketch, but it's perpendicular to your first sketch. Okay, that's my cell phone. All right, and I think it's not XY plane. There's a mistake here, but you can see from the picture, we should build this on YZ plane. So we'll build a new sketch and select this corner of the data coordinate system. You pick the YZ plane, and your sketch should be on this position. Okay, so your extrude and the first sketch might get in the way. You can just hide them. Okay, then in this state, then find the dimensions here. We'll start with profile tool. Then the bottom is point. Okay, try something else here. Then that was 0.35. Okay, you can zoom in, make sure this line is vertical. Actually, it doesn't matter because this is already in the solid. We're gonna unite these two solid anyway. And we'll use dimension tool, the infer dimension. Okay. So the bottom is 0.35. Yeah, that's right. Then 0.35. The height here is 0.057. It's the same for this one, 0.057. And the angle is 75 degrees. And the total height. Okay. So you want to pull away long enough so it'll be the vertical distance. And that'll be 0.16. And the sketch is done. Fully constrained, finished sketch. We can extrude and we can show the solid a little bit. So let's turn it into black here. This. Alright, then we will extrude this region boundary curve again. Maybe this. So the distance here is 0.325 total, and you want to do a symmetric left and right, and that's a half of 0.325. Okay, and you have the option to unite this extrude to the first one right away in this extrude command. Once you do that, you will have these two solid united into one piece. And the next is edge blends. So with the edge blends, it'll make it prettier. And let's see, the edge blends doesn't need some orders. You have to make the bigger radius first, then smaller radius. And also, this one goes for the second because this edge blend actually cuts into the first edge blend. So if you reverse order, it might not come out with the same results. Okay, we'll turn to static wireframe, edge blend, and the radius 0.03. You have to hit enter to change that. Otherwise, it'll stay for the first, stay at the first radius. Okay, so apply. That's the first. Then the second two edges are these two. Apply. Then the last is all around it. And as you can see, it turns out to be pretty weird because I haven't changed the radius now. So if you change it to 0.1, nothing happens, but you have to hit enter. Now the radius will actually change. So after this step, this piece is finished. If you want to take a look, you can hide the edges. Okay? You can also hide the sketches. So this button here will show all the objects. You can hide the stuff. Okay. And if you want to have a picture like what I have in the slides, that is a true rendering. Okay, so this will give you the perspective. It'll have some. I think it has perspective. Anyway, so this is the first piece. Then for the second part, the spring. The spring is a swept. Okay, and I found out you might not need the bridge curve here, but anyway, the idea is make a helix first, then make two datums on both ends, then draw a sketch on that for the extension. Then your sketch might not be tangent to the helix, so that's why I added a bridge curve between the sketch and the helix. If you are able to get this sketch to be tangent to the helix, then you don't need the bridge curve. Okay, then at last you just add a little section curve at the end, the circle, and do a sweep. Okay. So we'll turn this off, get a new one, then inches again. First is the helix. So we'll do insert curve helix. It's a 3D curve, so it's not in the sketch. So helix, then we have some parameters here. Okay, you can take a look in the slides. I have to take a look too. All right, so first the coordinate system, that'll be our coordinate system. Okay, and angle 0, diameter is 0.4, that's the outmost, minus 0.64, that is the diameter of the wire. Then that'll be the center of your wires. So the pitch is the same, okay, because that's so actually the spring will touch each other between the pitches, and the method will be turns. Default is limits, so turns, and the turn is 4 and a third. Right-handed, okay. Then that's the helix. Then on both ends we're gonna build a datum. So we'll build a datum plane, and this will be on curve method. You want to click on the curve, and this one should be tangent to the path. Okay, so your datum plane will look like this, and apply. Then we'll create another one, and also drag it to the end point. Make sure this arc length or arc length percentage is 0 or 100%. So now we build two sketches on both. So first the sketch top, okay, that's on the datum, but the coordinate system is kind of weird. You can drag the origin to this point, given you have these snap tools on. Sometimes I think it's off. Anyway, so you can drag that sketch origin onto the end point of the helix. Right, so this is the sketch. We have dimensions for that. Okay, so I'll try to well, let's just follow the slides, and we start with from this point connecting to the helix, and you want to make sure this is tangent. Okay, and also this line will be the reference line, the gap for the bridge, and the next line is collinear, then go down perpendicular, then we'll come back and take care of the fillet. Then dimension first, and since this is a very shallow angle, it's hard to get that dimension, so you want to change this invert to parallel dimensions. Then this will make sure it's the dimension is always parallel to your line. And this is the same as well. This is 0.5, and this dimension is 0.18. Okay, then this should be perpendicular. We'll set that back to inferred. Then this is fillet is 0.08, 0.08. I'll click the corner point. Done, and move it out. So we'll leave this as is. Try to see if this is tangent or not. So we're gonna use a sweep later, but I'm just use this tool, this filter to see if this is tangent. So it turns out it's tangent. So if that turns out to be tangent, you do not need to use the bridge curve. Okay. But for the purpose of showing how to use the bridge curve, we'll turn this to reference. So it's not connected now. Then we want a curve that is tangent on both sides. Okay, that is insert curve from curve and bridge. So there's a bridge curve, start object, end object, and make sure when you insert a bridge curve, you want to finish the sketch first. Otherwise, you will not be able to pick the helix because that's not in your sketch. So, by the way, here's a list of the reason commands. You can just come back and pick that. Start object, this one, end object, the helix, and you take a look at those symbols. This looks a lot like the tangent constraint, right? So these are tangent on both sides. And if you know more about the connectivity, we have actually more than tangent. You can make a curvature tangent, curvature continuity. So that is curvature. Well, that's just something extra. You don't have to know this. Okay, tangent would be enough. Okay, let's talk a little bit extra. So if it's tangent, like a fillet or edge blend, you can see a line there. Say, you notice this portion here, that is an edge blend. There's two lines. Why? Because it's tangent. It's not curvature continuity. If it's a curvature continuity, you will not see the line. That is isoline because it comes from straight line to a circle, to an arc. The curvature is a sudden job, so there's an isoline. If it's a continuous curvature, you will not see the line there. It's a little bit extra. Okay, so then we'll do the same for the bottom. Maybe without the bridge curve. So on plane, this curve, and yeah, the origin is on the endpoint because the helix starts from x-axis. So to make sure you can snap the origin, and somehow it becomes like this. It doesn't matter. So we'll try to draw without the bridge, and I think the bottom is indeed vertical or horizontal, but make sure, just to make sure. Then we'll go for the sketch. Then infer dimension, I'll start use shortcuts. That's a D, so I'll just use keyboard D. Yeah, 0.1. This is 0.5. Here is 0.18. Then we have a fillet, 0.08. Okay. Finish sketch, and hopefully this is indeed tangent. Then the next step is the section curve or the cross section of your spring. that is a little circle here, and we needed to have a data in there so we can make a sketch on top of that. So on curve, at the end of this curve, and you want this curve to be this data to be normal to the curve. So that should be look like that at the end point. And in case you are wondering why there's an arrow, this is the normal direction of your plane. You can change that because we always when you do a sketch, the normal is always pointing at you out of the screen. So if you have the normal look like this and you build a sketch, you know, you will look from the top. If it's the other way, you're gonna look like this. Right? Either way. So the origin really doesn't matter. We'll leave it there. Just draw a circle here, and remember that is 0.064. Okay, and the finished sketch. Then we'll use a swept. So the section is very simple, just the circle. The guide curve is the whole thing. Once you click, if they're tangent, they're gonna go all the way to the end. If somewhere it's not tangent, it's gonna stop there. So seems like my sketch turned out pretty good. I really don't need the bridge curve. And that is all for the spring. So thank you for watching. I hope you enjoy the modeling process.